Let us recall the what property as we have discussed earlier is what? A bar cross B bar whole square is equal to mod A whole square mod B whole square. This is minus A bar dot B bar whole square. As we know already, A dot A is equal to mod A whole square is equal to A bar square or else A square. By using that, I can write A bar cross B bar whole square is equal to mod A whole square mod B whole square minus A dot B whole square. By using this property, we shall have one more application. What is that? Let I, j, k be the orthonormal right-handed system of vectors. Right-handed system of vectors, and A bar cross R bar is equal to J, then A bar dot R bar is equal to dash. It's an application of what? This concept. Let us discuss about this. The proof of this one is, we know that modulus of A bar cross B bar whole square is equal to mod A whole square mod B whole square minus A dot B whole square. In place of A bar, in place of B bar, R bar, I can write A bar cross R bar whole square is equal to mod A whole square mod R bar whole square, then A bar dot R bar whole square. But A bar cross R bar is equal to J modulus of J whole square is equal to mod A whole square mod R bar whole square A bar dot R bar whole square. You transfer this side, I can write 1 is equal to mod A whole square mod R bar whole square A bar dot R bar whole square. So therefore, A bar dot R bar whole square is equal to, that is a modulus of A bar whole square minus R bar whole square minus 1, which implies A bar dot R bar is equal to plus or minus mod A whole square mod R bar whole square minus 1 is the value of what? A bar dot R bar. A bar dot R bar. You can give any values for what? If you take the what modulus of A is equal to some vector, some magnitude, and R bar is equal to some vector as ijk, that gives the value of what? A bar dot R bar, and as well as what? Mod A whole square or what? Mod R bar whole square. This is the one of the application of what? Modulus of A cross B whole square mod A whole square into mod B whole square minus A bar dot B bar whole square. Yes. By the definition of cross product, we have come across, if I take A bar, if I take B bar, this is the angle between them. This is nothing but n cap. This is nothing but A bar cross B bar. This may be like this. This is what? Minus n cap. So therefore, this is A cross B. I can also go like this. This is B cross A. Here A cross B. Now, if you go in a what? Anti-clockwise direction, A cross B is generated along n cap and B cross A is generated along what? Minus n cap. A bar, B bar, n cap forms a right-handed system. B bar, A bar minus n cap forms a what? Right-handed system. Now the thing is, the very first point we have to notice from this figure is, if A bar, B bar are non-zero, non-parallel vectors, then A bar cross B bar is the vector perpendicular to the plane of A bar comma B bar. So when A cross B is the vector which is perpendicular to the plane containing A bar and B bar, it's a vector. Then B cross A is also a vector perpendicular to it. So therefore, now A cross B is the vector which is perpendicular to the plane containing A bar and B bar. As you know already, how many unit vectors which are perpendicular to the plane containing A bar and B bar? There are two vectors. One is n cap, other is what? Minus n cap. So therefore, the number of vectors, the next point is the number of unit vectors which are perpendicular to the plane of A bar comma B bar are 2. That is plus or minus n cap. Here A cross B is the vector which is collinear with what? N cap. A cross B is a vector. I want to convert in terms of what? Unit vector. So therefore, I can write n cap is equal to, that is A bar cross B bar by modulus of A bar cross B bar. This is the vector which is perpendicular to or normal to the plane containing A bar and B bar. Here, n cap and this vector are in the same direction, positive direction. Now minus n cap, similarly, I can also write n cap is equal to minus of A bar cross B bar by modulus of A bar cross B bar. This is in opposite direction. This is in the what? Same direction. As I told, the number of unit vectors which are perpendicular to the plane containing A bar and B bar are mainly 2 plus or minus n cap. N cap is equal to A cross B by modulus of A cross B. Meanwhile, minus of A cross B by what? Modulus of A cross B. After knowing this concept, let us move to find out the vector of length lambda which is perpendicular to the plane containing A bar and B bar. A bar and B bar. Next point is the vector of length lambda which is perpendicular to the plane containing the vectors A bar comma B bar is lambda into A bar cross B bar by modulus of A cross B. In fact, you can take this one as plus or minus lambda into A bar cross B bar by modulus of A cross B. Plus indicates same direction, minus indicates what? Opposite direction. If you do not want to represent with plus or minus, it can be assigned to lambda. If lambda takes positive value, positive direction. If lambda takes what? Negative value, negative direction. On the whole, the vector of length lambda perpendicular to the plane containing A bar and B bar is lambda into A cross B by modulus of what? A cross B. Let us take A bar. This is B bar. This is the angle between them. Up to here, I take this n cap. I take this what? Vector A cross B is the vector which is perpendicular to A bar and B bar. Meanwhile, it is collinear with what? N cap. N cap is the unit vector which is perpendicular to the plane generated by what? A bar and B bar. So therefore, up to here, if it is a unit vector n cap, its magnitude is 1. I want the vector of length lambda. Remember, in vectors, if you want a vector of required length, that required length has to be multiplied with unit vector. So therefore, I take this is up to here. This is nothing but lambda into A bar cross B bar by modulus of A bar cross B bar. Why? We made what? N cap is equal to, what is n cap? In terms of A cross B by what? Modulus of A cross B. That is also unit vector. I want a vector of length lambda which is perpendicular to both A bar and B bar, means just you multiply lambda into what? A bar cross B bar by modulus of A cross B. In turn, if you take the modulus of A cross B by modulus of A cross B, it will be 1. 1 into lambda. Once again, required length is what? Lambda. That's what we want, the vector. So therefore, the vector of length lambda which is perpendicular to both A bar and B bar is lambda into what? A cross B by modulus of A cross B. Right. After knowing the concept of vector of length lambda perpendicular to both of A bar and B bar, let us have still the clarity about this concept by taking one example. What is example? A vector of magnitude root 6 which is perpendicular to both I plus j plus k and 2i plus j plus 3k. Yes, you take this one as, you take A bar is equal to I plus j plus k, B bar is equal to 2i plus j plus 3k, B2 vectors, and lambda is equal to how much? Root 6. Let us find out A bar cross B bar, because in this concept lambda into A cross B by modulus of A cross B, we know it. It's I, j, k, A1, A2, A3, B1, B2, B3, 1, 1, 1, 2, 1, 3. This is I into, now leave this row, this column, 1, that is AD minus BC, A, B, C, D. Therefore 3 minus 1 minus j into, leave this column, this row, 1 into 3, 2 into 1. Therefore 3 minus 2 plus k into, leave this row, this column, 1 into 1, 2 into 1, 1 minus 2. Therefore 2i minus j minus k, correct? This is A bar cross B bar. Find its magnitude. A bar cross B bar is equal to 4 plus 1 plus 1 is equal to how much? It's what? Root 6. I want the vector of length lambda. I can write lambda is equal to root 6 perpendicular to both A bar and B bar is equal to lambda into A cross B by modulus of A cross B. I can write lambda is equal to root 6 into, yes, come on, A cross B. What is A cross B? That is 2i minus j minus k by what? Root 6. Root 6 goes. The required answer is what? 2i minus j minus k is the vector of length what? Lambda, root 6 perpendicular to both A bar and B bar. Now, if I take, you see, if I take, this is A bar, if I take B bar, this is theta. This is nothing but A bar cross B bar. This is nothing but n cap. So now whole this plane, this board is a what plane? In this plane, A bar, B bar, C bar is also lying in this, irrespective of the position may be. When A bar, B bar, C bar are lying in a same plane, then I want to find out a vector or a unit vector which is parallel to the plane of A bar and B bar, parallel to A bar and B bar, and perpendicular to what? C bar. Now by definition I start. Let A bar comma B bar comma C bar be three non-zero, non-parallel vectors. Then the unit vector parallel to the plane of A bar comma B bar and perpendicular to the vector C bar is A bar cross B bar cross C bar by modulus of A bar cross B bar cross C bar. Let us analyze this. By definition of cross product, A cross B is the vector which is perpendicular to both A bar and B bar. Then you define a cross product. Maybe here you can take. You define a cross product. It will be like this. What is this? This is the cross product of A cross B and C bar. I can write A cross B cross C bar. This may be, anyhow, this, what is the concept of what? A cross product? A cross B cross C bar. This is also a vector which is perpendicular, which is what? Perpendicular to A cross B as well as what? C bar. When this is perpendicular to this, it is parallel to the plane of what? A bar and B bar. And also perpendicular to what? C bar. So therefore, remember, A cross B cross C bar by modulus of A cross B cross C bar is the vector which is parallel to the plane of A bar and B bar and perpendicular to the what vector? C bar. Now, let us discuss about vector area. In geometrical interpretation of cross product or vector product, we come across about the area of a parallelogram with adjacent sides A bar and B bar as modulus of A cross B. Meanwhile, area of a triangle with the sides A bar and B bar as half into what? Modulus of A cross B. Those two were scalar areas. Instead of scalar area, maybe parallelogram, maybe quadrilateral, maybe what? Triangle, etc. We want vector area. Means the area can also be represented with what? Vector notations. So therefore, I take a what? A be the plane curve. Let A be the plane curve, okay, and n cap be the what? Unit vector perpendicular to the plane, then the vector area is denoted by A into n cap. Means whatever the area you are getting, multiply with what? Unit vector. Let us discuss in another way. Let A be the what? Region, area of the region bounded by the curve C, and n cap be the unit vector perpendicular to the plane in anti-clockwise direction. Then A into n cap is denoted by the area of a what? Curve in vector notation. So therefore hereafter A into n cap represents a what? Vector area. Let us see how to find out the vector area of a triangle and vector area of a what? Parallelogram. Followed? The vector area of triangle ABC is delta is equal to half into AB bar cross AC bar, half into BA bar cross BC bar, half into CA bar cross CB bar. Let us see how it is. Now, for this one is, you take a triangle A, this is B, it's a C. Now if I take this is AB bar and AC bar, first let us focus my attention on this, then you can generalize. Now, the proof of this one is, in a triangle ABC, the area of triangle ABC, delta is equal to half into modulus of AB bar, AC bar, angle between these two is what? Sin A. But I want vector notation. I can write vector area is equal to delta n cap. So therefore I can write half into modulus of AB bar, modulus of AC bar, sin A into n cap. Am I correct? By definition of cross product, I can write, by definition of cross product, A bar cross B bar is equal to mod A, mod B, sin theta into n cap. This is nothing but half into AB bar cross AC bar. So therefore, in the similar fashion, we can also find out the area of the triangle formed by the what? Sides BA and BC. Similarly, CA and CB as delta is equal to half into AB bar cross AC bar, half into BA bar cross BC bar, half into CA bar cross CB bar. These formulas represents what? The vector area of a triangle what? ABC. Now I have taken what? Sides. Instead of taking the sides, when you are given with the position vectors of the vertices as A bar, B bar, C bar, what is the what? Vector area of a triangle? Let us see. Now, after this, if I take the triangle ABC, or else A, this is what? B, this is what? C. See, if I take this is A bar, if I take this is B bar, this is what? C bar, or else this is what? C bar. This is B bar, this is what? C bar. I can also write the area of triangle, vector area of a triangle is equal to half into A bar cross B bar, or else I can also write B bar cross C bar. I can also write what? C bar cross A bar, when they represent what? The area of a triangle with the sides A bar, B bar, C bar. If I take this as AB bar as a bar, AC bar as a what? B bar, and this as a what? C bar. You can also write the area of a triangle is equal to half into A cross B, half into B cross A, half into C cross A. The vector area of triangle ABC with vertices having position vector vectors A bar, comma B bar, comma C bar, then the area of triangle ABC delta is equal to half into modulus of A cross B, B cross C, C cross C. Let us take the triangle A of A bar, B of B bar, C of C bar as the position vectors of its vertices. Now I start. Let OA bar is equal to A bar, OB bar is equal to B bar, OC bar is equal to C bar be the PVS of the vertices capital A, comma B, comma C respectively. Area of triangle ABC, we are discussing about vector area. Area of triangle ABC, you can go by half into AB bar cross AC bar. You can also take BA bar cross BC bar. You can also write CA bar cross CB bar as you please. All will be same, and half into AB bar cross AC bar and half into what? BA bar cross BC bar, half into CA bar cross CB bar. After simplification, they lead to half into, that is A bar cross B bar plus B bar cross C bar plus C bar cross A bar. Let us see how it is. Now, AB bar, the vector that is side is not given, its position vectors are given. I can write AB bar as half into OB minus OA cross OC minus OA. This is equal to half into, this is B bar minus A bar cross of C bar minus A bar. One vector can be expressed as position vectors of its extremities. Take ordinary cross product B cross C minus B cross A minus A cross C minus of minus A cross A. Followed? What is A cross A? 0. Now I change it as B cross C. This is A cross B, this is C cross A plus 0. Therefore, I can write delta is equal to half into A bar cross B bar, B bar cross C bar, C bar cross A bar. This represents the vector area of a triangle with the vertices A bar, B bar and C bar. I can also write scalar area of a triangle provided if I take a modulus on it. So therefore, now you can also write the scalar area is equal to, that is half into modulus of A cross B, B cross C plus C cross A. Here you get one vector. This is also a vector, this is also a vector, this is also a vector. It's a sum of three vectors. Addition of three vectors leads to one vector after finding the magnitude that gives what? Scalar. So therefore, every area of a triangle can be represented either by vector or by scalar. This is scalar area, this is what? Vector area. And if I cross multiply this can be written as 2 delta into what? A cross B, B cross C, C cross C. Remember, whenever, wherever you come across modulus of A cross B plus B cross C plus C cross A, this represents the area of twice the area of a triangle, followed by the position vectors A bar, B bar, C bar. That is 2 delta is equal to modulus of A cross B plus B cross C plus C cross C. Yes, we have come across the area of a what? Vector area of a triangle and a scalar area of a triangle. Meanwhile, 2 delta is equal to modulus of this quantity in this concept. Let us discuss about what? The vector which is perpendicular to the plane containing A bar, B bar, C bar as a position vectors of 3 points capital A, B, C. I want to find out the vector perpendicular to the plane containing the points A of A bar, B of B bar, C of C bar. Okay, if I take this as A of A bar, B of B bar, C of C bar, if we join these two, it can become a triangle. Every triangle is a plane. So therefore, you define a vector product in anti-clockwise direction. This is nothing but n cap. This is defined to be AB bar cross AC bar. By definition of cross product, AB bar cross AC bar is the vector which is perpendicular to the what? AB bar and AC bar. I mean perpendicular to the plane containing A of A bar, B of B bar and C of C bar. Let us start. Let OA bar is equal to A bar, OB bar is equal to B bar, OC bar is equal to C bar be the position vectors of PVS of 3 points capital A, B, C respectively. By definition of cross product or vector product, the vector perpendicular to the plane containing A bar, B bar, C bar is equal to AB bar cross AC bar. This is nothing but OB minus OA cross OC minus OA. This is nothing but B bar minus A bar, C bar minus A bar. Take the cross product. B cross C, this into this, minus B cross A, this into this. Next, minus A cross C, minus of minus plus A cross A. We know that A cross A is the vector, and also angle between them is what? 0. Its value is 0. And meanwhile, A cross B is equal to minus B cross A. So therefore, I can write this one as B cross C plus A cross B. Change the cross product. Next, it's a what? C cross A plus 0. I can write A cross B plus B cross C. It's a C cross A is the vector which is perpendicular to the plane containing A of A bar, B of B bar, C of C bar. When this is a vector, let me find out the unit vector which is perpendicular to the plane containing A of A bar, B of B bar, C of C bar. That is the unit vector. The unit vector perpendicular to the plane containing A of A bar, B of B bar, C of C bar is equal to AB bar cross AC bar whole divided by modulus of AB bar cross AC bar. So now I can write this one as this is equal to that is A bar cross B bar plus B bar cross C bar, C bar cross A bar by A cross B, B cross C, C cross A. A cross B plus B cross C plus C cross A by A cross B plus B cross C plus C cross A. This is the unit vector which is perpendicular to the plane containing A bar, A of A bar, B of B bar, C of C bar. Now, let us start the another application of cross product. The perpendicular distance from the point A of A bar to the line joining of 2 points B of B bar and C of C bar. The perpendicular distance from the point A of A bar to the line joining B of B bar and C of C bar. Okay, you select, this is B of B bar, this is C of C bar, this is a point A of A bar, this is. Now this is AD is nothing but a what? Height or altitude, we call it as. If you join all the 3 points, it forms a triangle. So therefore, this AD is the altitude or a what? Height. So I want to find out the perpendicular distance from this point A of A bar to the line through B of B bar and C of C bar. So I start. Let OA bar A bar, OB bar is equal to B bar, OC bar is equal to C bar be the position vectors of capital A, comma B, comma C respectively. Now, the length of altitude is equal to the perpendicular distance. The perpendicular distance from A of A bar to BC bar is equal to AD. This AD is nothing but I can write half into or else 2 delta. 2 delta by base, you know already from the what? Fundamental. The length of the altitude is equal to twice the area of a triangle by what? Base. So therefore, now I can write twice, I can write half into modulus of AB bar cross AC bar by what is base? Modulus of BC bar. I can write 2 to get cancels. So therefore, modulus of AB bar cross AC bar by modulus of BC bar. Now, what is AB bar cross AC bar? It's a OB minus OA cross OC minus OA whole divided by OC minus OB. Now, this is nothing but B bar minus A bar cross C bar minus A bar by C bar minus A bar, C bar minus B bar. Okay, now this is nothing but already we are habituated from many concepts. Just now I told this cross product gives us what? A bar cross B bar. This is B bar cross C bar. This is C bar cross A bar whole divided by C bar minus B bar. This is nothing but the length of the altitude from A of A bar to the line through B of B bar and C of C bar. In the place of similarly, we can also find out the perpendicular distance from B of B bar to the line joining of C and A. In that case, if it is B, I can write like this. If I go for B, if I go for C, it's a A, correct? It is half into modulus of BC bar cross BA bar by modulus of CA. Similarly, if I go for what? If I take this one as perpendicular distance from what? B or else C to the what? AB. Now this is nothing but perpendicular distance. This is nothing but perpendicular distance. Yes. Now from C to the line AB. Now this is given to be what? Half into CA bar cross CB bar by what? Modulus of BC. Modulus of AB. And into what? Twice the area of a triangle. Then it gives what? Perpendicular distance. In the same fashion, we can write the perpendicular distance from B to what? AC or CA, from C to what? AB. Let us see. Similarly, the perpendicular distance from first one, B of B bar to AB. or AC is equal to modulus of A bar cross B bar cross C bar cross A bar by modulus of AC. I can write this one as, that is A bar cross B bar cross C bar plus C bar cross A bar by modulus of C bar minus A bar. This is second one. The third one is the perpendicular distance from C of C bar to AB is equal to modulus of A cross B cross C cross A by modulus of AB. Modulus of AB means B bar minus A bar. This is how you can find out the perpendicular distance from the point A of A bar to what BC, or from B of B bar to what AC, to what from C of C bar to the what AB.